The thermometer nailed to Soren Haldor's cabin wall read 74 degrees on a February morning when the outside air had frozen solid at 29 below zero. Inside cabins, a mile down the valley, families huddled around fires that couldn't keep the cold from seeping through dirt floors, while Soren walked barefoot across his floor, warmed by hundreds of tons of volcanic rock beneath his feet. Before we dive in, let us know where you're watching from, and if stories like this move you, hit that subscribe button, because tomorrow's episode is even more unbelievable than this one. The year was 1851. The volcanic plateau region of the Idaho Territory stretched across a landscape that seemed designed to test human endurance. Black basalt formations jutted from earth that froze solid from November through March. Sparse stands of pine provided barely enough timber for construction and fuel. Water sources froze to the bottom during the coldest weeks. Men and women who settled this country did so knowing the land would try to kill them with systematic efficiency. Soren Haldor had survived 4 winters in this environment. He had arrived in the spring of 1847 with his wife Astrid, drawn by the promise of land that cost nothing but the willingness to endure. They had built a cabin using methods common across the American frontier. Logs cut from nearby pine stands, notched at the corners, stacked to form walls roughly 12 feet by 16 feet. A single door, 2 small windows covered with oiled paper, a dirt floor packed hard by foot traffic and time. The cabin kept out wind and rain. It provided shelter from summer sun and protection from autumn storms. But in winter, it became a structure that could barely sustain life. The dirt floor, despite being packed and covered with pine needles and hides, remained perpetually cold. Frost formed on the inside walls when temperatures dropped below zero. The fireplace, built from river stones and mud mortar, consumed enormous quantities of wood but heated only the immediate area around the hearth. 3 feet from the fire, the temperature dropped precipitously. 6 feet away, breath formed visible clouds in the air. Soren and Astrid spent winters sleeping as close to the fire as safety allowed. They wore every piece of clothing they owned in layers. They heated stones in the fire and placed them beneath their blankets for temporary warmth that faded within hours. They burned through wood supplies that represented weeks of cutting and hauling. And still, the cold crept in through the floor, through the gaps between logs, through the very earth beneath their feet. This was normal. Every settler in the region lived the same way. Some cabins were slightly better built, some fireplaces were marginally more efficient. But fundamentally, winter on the volcanic plateau meant constant battle against cold that came up from the frozen ground and pressed down from the sky with equal insistence. People accepted this as the cost of claiming free land in a harsh territory. Soren had accepted it too, until the winter of 1851, when acceptance stopped being possible. That winter would change everything he understood about survival in cold country. But the change would begin not with innovation or insight, but with loss that made continuing in the old way unbearable. February brought temperatures that dropped below zero and stayed there for weeks. The cold was not dramatic, it simply existed, constant and merciless, draining heat from everything it touched. Soren kept the fire burning day and night. He hauled wood from his dwindling stockpile every few hours. He and Astrid slept in shifts so someone could maintain the flames. It was never enough. Astrid developed a cough in early February. The sound was harsh and wet, coming from deep in her chest. She continued her work because there was no choice. Water needed hauling despite the ice. Meals needed cooking. The fire needed constant feeding. She moved through these tasks with increasing difficulty. Her breathing labored, her face flushed with fever that had nothing to do with warmth. Soren watched her decline with growing fear. He knew what pneumonia looked like. He had seen it kill 3 people in the settlement the previous winter. He kept the fire higher, burning through wood at an unsustainable rate. He heated stones and placed them around her sleeping area. He boiled water to create steam in the cabin's cold air. Nothing helped. The dirt floor radiated cold that no fire could overcome. Astrid lay on their bed, elevated 2 feet above the ground on a simple frame, but the cold rose from below like water seeping through soil. Her body fought the illness and the relentless chill simultaneously. The combination was too much. She died on February 14, 1851, in the hour before dawn. Soren was sitting beside her feeding the fire when her labored breathing simply stopped. The silence that followed was absolute. Outside, the wind had died. Inside, the fire crackled softly. Astrid was still. Soren sat without moving for a long time. The fire burned down. The cabin grew colder. He eventually stood and walked outside into air so cold it burned his lungs. The sky was clear. Stars filled the darkness with light that provided no warmth. He stood in the frozen night and felt something inside him break in a way that would not heal. He buried Astrid 2 days later on a hillside a quarter-mile from the cabin. The ground was frozen 18 inches deep. It took him 6 hours to dig a grave using a pickaxe and shovel, breaking through frozen earth in fragments. Bjorn Lunde and Magnus Viker came to help. They stood with him in the cold while he filled the grave and marked it with stones. They offered condolences in few words. There was nothing useful to say. Soren returned to the cabin alone. He stood in the center of the single room and felt the cold rising through the dirt floor beneath his feet. The fire burned in the hearth, but the floor remained frozen. He understood something in that moment with absolute clarity. The cabin had killed Astrid as surely as the pneumonia. The cold coming up through the ground had drained her strength until she had nothing left to fight with. The realization consumed him. Soren stopped trapping. He had lines set across 3 miles of territory, snares and deadfalls placed at beaver runs and game trails. He ignored them all. The work that had occupied his days for 4 years became irrelevant. He left the cabin only to gather firewood and haul water. The rest of his time he spent thinking about cold and floors and the fundamental problem of heat rising while cold sank. He began walking the volcanic plateau in widening circles around his cabin. The landscape was scattered with basalt formations, remnants of ancient lava flows that had created the region's characteristic black rock. The stones ranged from small fragments to massive boulders weighing tons. Most settlers viewed them as obstacles, impediments to plowing and building. Soren started seeing them differently. On a cold March morning, he placed his bare hand on a basalt outcropping that stood 3 feet above the snow. The stone was cold, but noticeably warmer than the air. He left his hand there, feeling the temperature difference. The sun had been up for 2 hours. The black stone had absorbed solar radiation and retained it. He moved to another outcropping in full shadow. That stone was colder, but still warmer than the surrounding air. Soren began conducting experiments with the systematic focus of someone who had found purpose. He collected basalt stones of various sizes and placed them around his fire in the evening. In the morning, he checked their temperature by touch. Larger stones retained heat longer. Denser stones held warmth better than porous ones. Stones placed in contact with each other seemed to maintain temperature longer than isolated stones. He dug test holes near his cabin, placing stones at various depths and monitoring them over days. Stones buried 1 foot deep stayed warmer than surface stones. Stones at 2 feet depth were warmer still. He realized the earth itself held heat, particularly earth insulated by stone mass above it. The volcanic plateau sat above geothermal activity. The warmth was subtle but measurable. Over 3 weeks, Soren developed an understanding that had no formal education behind it but was grounded in careful observation. Volcanic rock had thermal mass. It absorbed heat from any available source and released it slowly over time. A large enough mass of stone, properly positioned, could store significant heat during warm periods and release it gradually when temperatures dropped. The principle was simple. The application required thinking about cabin construction in a completely different way. Other settlers noticed Soren's behavior. Bjorn Lunde found him one afternoon, kneeling beside a pile of basalt stones, arranging and rearranging them in patterns. Bjorn asked what he was doing. Soren said he was planning a new cabin. Bjorn looked at the stones and then at Soren's existing cabin, which was perfectly serviceable by frontier standards. He shook his head and walked away. The other man had clearly lost his mind to grief. Spring arrived gradually on the volcanic plateau. Snow melted in patches, revealing black earth and scattered stone. Soren emerged from winter with a plan that seemed insane to everyone who heard it. He was going to build a new cabin. The foundation would be constructed entirely from volcanic rock. The floor would rest on top of this stone platform. The thermal mass would keep the floor warm through winter. Magnus Viker was the first to hear the complete explanation. He listened with increasing disbelief as Soren described his intentions. Build a foundation from hundreds of tons of stone, haul basalt from lava fields miles away, stack it in courses 2 to 3 feet thick? Magnus asked the obvious question. Why would anyone build a cabin on top of cold stone? Stone was cold. Stone conducted heat away from structures. Everyone knew this. Soren tried to explain thermal mass, heat retention, and gradual release. He talked about his experiments with buried stones and fire-heated rocks. He described how volcanic basalt stayed warmer than surrounding materials. Magnus listened, but understood nothing except that Soren planned to spend months doing what made no sense. A cabin needed a foundation that kept it level. Beyond that, simpler was better. Dirt floors had served frontier families for generations. Word spread through the scattered settlement. Soren Haldor was building a cabin on volcanic rock. The response was uniform mockery mixed with genuine concern. Grief had broken something in the man's mind. He was wasting time and effort on construction that would leave him with a colder cabin than what he already had. Stone floors were colder than dirt. This was basic knowledge. Bjorn Lunde confronted Soren directly. He rode to the cabin site where Soren had begun staking out dimensions. Bjorn was blunt. This was foolishness. Astrid's death had been tragic, but building a crazy cabin would not bring her back. Soren needed to trap, put in a garden, prepare for next winter in sensible ways. Building on stone was the opposite of sensible. Soren listened without arguing. He thanked Bjorn for his concern and continued working. He had no interest in defending his plans to people who would not understand the principle behind them. The thermal mass concept required accepting that stone could store and release heat over long periods. It required understanding that building up on stone was different from building directly on frozen ground. These were not intuitive concepts for men whose building knowledge came from tradition and necessity. Leif Nordstrom offered different criticism. Even if Soren's theory about warm stones was correct, the labor involved was absurd. Hauling hundreds of heavy stones, stacking them precisely, building a cabin on top, all of this would take months of brutal work. For what? A floor that might be slightly warmer? The effort-to-benefit ratio made no economic sense for a man trying to survive on the frontier. Soren absorbed the criticism and continued planning. Soren began the work in late April of 1851. The first task was stone selection, and he approached it with obsessive precision that surprised even himself. He needed hundreds of individual stones. Not just any volcanic rock would work. Each stone had to meet specific criteria he developed through trial and observation over the previous weeks. The primary lava field lay 2 miles northeast of his cabin site. Ancient volcanic activity had created a landscape of broken basalt formations, scattered boulders, and fields of fragmented rock. Soren walked this terrain for days, studying the variations in stone type, density, and structure. He learned to identify subtle differences that mattered for his purposes. Weight was the first criterion. Stones needed to be heavy enough to provide thermal mass, but light enough for one man to move with available tools. He settled on a range between 40 and 120 pounds per stone. Anything lighter lacked sufficient mass. Anything heavier could not be transported efficiently on the sled he planned to build. Density came second. Volcanic rock varied significantly in how porous it was. Some basalt was filled with air pockets from gas bubbles in the original lava. This stone was lighter, but held less heat. Denser basalt without significant porosity retained warmth far longer. Soren tested stones by hefting them, comparing weight to size. Dense stones felt heavier than their dimensions suggested. These were the ones he marked mentally for collection. Shape mattered for construction purposes. Soren wanted stones that were relatively flat on at least two sides. Rounded boulders would not stack efficiently. Irregular fragments would create gaps that reduced thermal contact between courses. He looked for stones that nature had broken along relatively straight planes, pieces that could be fitted together with minimal gaps. Surface texture provided clues about weathering and stability. Stones with heavily weathered surfaces had been exposed to freeze-thaw cycles that could create internal fractures. Soren preferred stones with smooth, dark surfaces that showed minimal weathering. These had either been recently exposed or had resisted degradation. They were more likely to remain structurally sound under the weight of stacked courses and cabin construction above. He developed a testing method. Each potential stone was struck with a hammer. Sound mattered. Dense basalt produced a sharp, clear ring. Porous or fractured stone gave a dull thud. The acoustic test became Soren's primary field assessment tool. He would strike a stone, listen, and decide within seconds whether it met his requirements. Over 6 weeks, Soren identified and marked approximately 600 stones scattered across the lava field. He used small cairns of white quartz fragments to mark each selected stone's location. From a distance, the lava field appeared dotted with small white markers, a map of his intended foundation visible to anyone who understood what they were seeing. Neighbors who saw him working thought the behavior confirmed his mental decline. Soren spent entire days in the lava field, striking stones with a hammer and listening to the sounds they made. He marked certain stones and ignored others with no pattern anyone else could discern. Magnus Viker watched from a distance one afternoon and rode away shaking his head. The man was lost to grief and obsession. Soren noticed none of this. He was focused entirely on identifying the right stones. Everything else was irrelevant. Moving 600 stones, weighing between 40 and 120 pounds each, across 2 miles of rough terrain, presented a logistics problem that absorbed Soren's complete attention through May and June. He needed a transport system that one man could operate alone. Standard wagons were too heavy for the volcanic plateau's uneven ground. Pack horses could not carry stones of the required weight. He needed something purpose-built. Soren spent 4 days constructing a heavy sled from pine logs. The runners were 8 feet long, hewn from straight-grained logs and shaped on the bottom surface to slide across ground with minimal friction. He connected the runners with cross pieces, bolted through with wooden pins. The bed was reinforced with additional bracing to handle concentrated weight. The entire structure was overbuilt by normal standards, designed to handle repeated stress of hauling 100-pound stones across broken ground. He rigged a harness system using rope and leather straps salvaged from old tack. The harness distributed pulling force across his shoulders and chest, allowing him to lean into the load and use his body weight for leverage. When the sled was loaded, he could drag it across relatively level ground through sustained effort. Uphill sections required different techniques, sometimes involving block and tackle anchored to trees or rock outcroppings. The work became brutally routine. Soren would walk to the lava field at first light, pulling the empty sled behind him. The 2-mile journey took 40 minutes. He would load stones onto the sled, usually 4 to 6, depending on their individual weights. The loaded sled weighed between 300 and 600 pounds. He would harness himself and begin the return journey. Pulling the loaded sled across 2 miles of volcanic plateau terrain took between 2 and 4 hours depending on the route and stone weight. The ground was uneven, scattered with smaller rocks that caught the sled runners. Sections of the route crossed areas where ancient lava had created surfaces as rough as broken glass. Other sections crossed soft volcanic soil that caused the runners to dig in, requiring constant adjustment of pulling angle to keep the sled moving. Soren made 1 round trip per day when conditions were good. Some days he made none, because rain turned the volcanic soil into adhesive mud that made hauling impossible. Some days he managed 2 trips by extending his working hours into evening, pulling the loaded sled by moonlight when the moon was full enough to see the route clearly. His body adapted to the work over weeks. Shoulders developed muscle, hands became calloused. His technique improved as he learned to read the ground ahead and choose routes that minimized resistance. He developed a rhythm of movement that allowed him to sustain effort for hours, a steady leaning pull that covered ground without exhausting him completely. By late June, he had moved approximately 200 stones to the cabin site. The pile grew slowly, each stone representing hours of effort. Neighbors occasionally passed by and saw the growing stack of basalt beside the staked-out foundation. The sight reinforced their certainty that Soren was wasting time on a project that made no sense. Bjorn Lunde stopped one afternoon and asked how long this foolishness would continue. Soren said he needed 400 more stones. Bjorn rode away without responding. The hauling continued through July and into August. By late August, Soren had accumulated enough stones to begin actual construction. The pile of volcanic basalt beside his staked foundation represented 3 months of brutal labor. Now came the work of transforming raw material into a functioning thermal mass system. He approached foundation design with the same methodical focus he had applied to stone selection and transport. The cabin footprint was marked at 14 feet by 18 feet, slightly larger than his previous structure. Soren wanted more interior space, but size was limited by the spanning capability of pine logs available for roof beams. The foundation would extend 3 feet beyond the cabin walls on all sides, creating a platform 20 feet by 24 feet. This extension was critical to his design. The additional stone mass would absorb and store heat, creating a thermal buffer around the cabin's perimeter. Soren began by excavating the foundation area. Most frontier builders simply cleared surface debris and built directly on ground. Soren dug down 8 inches across the entire 20 by 24 foot area. The excavation removed topsoil and organic material that would decompose and settle over time. He wanted his foundation resting on stable volcanic subsoil that would not shift or compress under the weight of stacked stone. The excavated area was leveled using a simple but effective technique. Soren filled the depression with 4 inches of crushed volcanic rock, small fragments he collected from areas where basalt had weathered into gravel. He raked this base layer level and tamped it firm by walking across it repeatedly. The crushed rock created a stable, draining base that would prevent moisture accumulation beneath the foundation. Water was the enemy of thermal mass. Wet stone conducted heat away rather than storing it. Foundation construction began with the largest stones. Soren sorted his collection, identifying the heaviest and flattest pieces. These formed the first course, the base layer that would support everything above. He positioned each stone carefully, using smaller rock fragments as shims to ensure each piece sat level and stable. The stones were fitted as tightly as possible, but Soren deliberately left small gaps between them. The gaps were counterintuitive but essential. Solid stone construction with no airspace would conduct cold efficiently from ground to surface. Air gaps created insulation. More importantly, they allowed air circulation through the foundation mass. Moving air would help distribute heat throughout the stone volume, preventing cold spots and ensuring even thermal performance. The gaps were typically 1 to 2 inches wide, enough for airflow but not so large that they compromised structural integrity. The first course took 2 weeks to complete. Soren worked alone, positioning stones that sometimes weighed over 100 pounds without mechanical advantage beyond wooden levers and fulcrums. He developed techniques for rolling stones into position, using leverage to achieve what strength alone could not. Each stone was tested for stability before he moved to the next. If a stone rocked or shifted when weight was applied, he removed it and adjusted the base until it sat perfectly firm. The second course followed the same principles but used medium-weight stones, pieces in the 60 to 90-pound range. The second course of foundation stones went down through September. Soren positioned each piece to bridge the gaps in the course below, creating an interlocking pattern similar to brickwork. The principle was load distribution. Weight from above needed to spread across multiple stones rather than concentrating on single points. Each stone in the second course rested on at least 2 stones below, sometimes 3 or 4 depending on size and placement. Soren observed patterns as the foundation rose. Certain arrangements created more stability than others. Longer stones oriented perpendicular to the course below provided better structural bridging. Stones with similar thickness across their length created more uniform bearing surfaces. He adjusted his placement strategy based on these observations, developing intuitive understanding of structural principles that engineers would recognize but could not have explained in formal terms. The thermal mass engineering happened simultaneously with structural construction. Soren was building for 2 purposes: supporting the cabin weight and storing heat. The balance between these requirements shaped every decision. Thicker foundation meant more thermal mass, but also more weight and material. He settled on a final height of 30 inches, 3 courses of stones averaging 10 inches thick each. Air circulation through the foundation remained a priority. As each course went down, Soren ensured gaps aligned vertically in places, creating chimneys that would allow air movement from bottom to top of the stone mass. These vertical channels would help distribute heat absorbed at the surface down into lower courses. They would also prevent moisture accumulation by allowing evaporation and air exchange. The top course required the flattest stones. The cabin floor would rest on this surface, and irregularities would translate to an uneven floor. Soren used his smallest stones here, pieces in the 40 to 60-pound range that he could position with precision. He checked level constantly using a straight edge and a bowl of water. If the water surface was parallel to the straight edge when laid across stones, the surface was level, primitive, but effective. By early October, the foundation was complete. The structure was massive by frontier standards. Approximately 570 stones, stacked in 3 courses, created a platform that weighed roughly 30 tons. The foundation extended 3 feet beyond the planned cabin walls on all sides. From a distance, it looked like an ancient ceremonial platform, a rectangular mass of dark stone rising 30 inches above the surrounding ground. Neighbors came to see the finished foundation. Magnus Viker walked around it slowly, examining the construction. He admitted the stonework was impressive. The foundation was level, stable, and clearly built with skill, but he still could not understand the purpose. Why build this massive stone platform to support a small cabin? Soren explained again about thermal mass and heat storage. Magnus nodded politely, but his expression showed he considered it elaborate foolishness. Soren did not care about convincing anyone. The foundation was built. Now came the cabin itself. Cabin construction began in mid-October of 1852. Soren had spent an entire season building the foundation. Now he would build the structure that foundation would support. The work followed standard frontier methods in most respects, but with critical modifications based on his thermal mass design. The logs came from pine stands 3 miles west. Soren selected trees carefully, looking for straight trunks, 12 to 14 inches in diameter. He cut, limbed, and hauled 28 logs over 2 weeks. The logs were notched using simple saddle joints at the corners. Soren was a competent carpenter, but not exceptional. His log work was adequate, creating walls that were reasonably straight and gaps that could be chinked effectively. The critical difference was the floor system. Standard frontier cabins had floors built directly on the ground or on simple log runners laid across dirt. Soren's floor would rest on top of the volcanic stone foundation with an air gap beneath. This gap was essential to his design. The space would allow heat radiating from the stone mass to warm the floor from below without direct contact that might conduct heat away too quickly. Soren built the floor frame using smaller pine logs as joists. These joists rested directly on the top course of foundation stones running perpendicular to the cabin's length. He spaced them 16 inches apart, closer than standard construction. The tight spacing would support floor planks without sagging and create multiple pathways for heat transfer from stone to wood. The air gap beneath the floor was 6 inches. This dimension came from experimentation during his testing phase. 6 inches allowed adequate airflow while keeping the floor close enough to the stone mass to receive radiant heat effectively. Larger gaps would reduce heating efficiency. Smaller gaps would restrict air circulation and potentially trap moisture. Floor planks were hewn from pine logs, split lengthwise, and smoothed on one side with a draw knife. Soren had no access to milled lumber. Each plank required hours of work to create a reasonably flat surface. He fitted the planks tightly, leaving minimal gaps between them. The floor needed to be as airtight as possible to prevent heat loss through cracks. The cabin walls rose during November, 4 walls of notched logs, chinked with a mixture of clay and moss, 2 small windows on the south wall to capture winter sun, a door on the east side, simple construction that any frontier builder would recognize. The only unusual feature was the relationship between cabin and foundation. The walls rested on floor joists that rested on stone. The entire cabin structure sat elevated 36 inches above ground level when foundation height and floor gap were combined. This elevation created an unexpected benefit Soren had not anticipated. The cabin was above the ground level cold zone where frost accumulated and cold air pooled. Winter temperatures varied by height. Air at ground level could be 10 degrees colder than air 3 feet up. By elevating his cabin, Soren had inadvertently placed his living space in a slightly warmer microclimate. The roof went on in early December. December brought the first serious cold. Temperatures dropped below freezing at night and barely climbed above during the day. Soren worked steadily to complete the cabin interior before winter fully arrived. The roof was finished, a simple gable design covered with split shakes. The door was hung and fitted. The windows were covered with oiled paper that allowed light but blocked wind. The fireplace represented Soren's most significant departure from his previous cabin design. Most frontier fireplaces were large, intended to produce maximum heat output. Soren built a small fireplace, barely 3 feet wide. The opening was proportionally smaller than standard construction. The firebox was shallow. The entire structure seemed inadequate for heating a cabin through a plateau winter. The fireplace design was intentional. Soren did not need massive heat output if his floor provided baseline warmth. The fireplace only needed to supplement the radiant heat coming from the volcanic foundation. A small, efficient fire would be adequate. It would consume less wood, produce less smoke, and require less maintenance than the roaring fires his neighbors would burn all winter. Soren built the fireplace from river stones, using clay mortar mixed with sand for durability. The chimney was narrow, rising 8 feet above the roof peak. He included a smoke shelf inside the chimney, a horizontal ledge that deflected downdrafts and reflected heat back into the room. The feature was common in quality construction, but rare on the frontier where speed mattered more than efficiency. Interior finishing consumed the rest of December. Soren built a sleeping platform against the north wall, elevated 2 feet above the floor. Storage space beneath. A simple table and 2 benches. Shelves mounted on the walls for supplies. Everything was utilitarian, built for function rather than appearance. He was a widower living alone. Comfort mattered more than aesthetics. By late December, the cabin was ready for occupancy. Soren moved his possessions from the old cabin to the new structure. The process took 1 day. He owned little beyond basic tools, trapping equipment, cooking implements, and bedding. Everything fit in the new cabin with room to spare. The first night in the completed cabin, Soren did not light a fire. He wanted to understand the baseline thermal performance before adding heat from combustion. The outside temperature was 15 degrees. Inside the cabin, with no fire, the temperature held at 42 degrees. The floor was noticeably warmer than the air, probably 50 degrees based on how it felt to bare feet. The warmth was coming from the foundation. 3 months of autumn sun had poured energy into 30 tons of volcanic rock. That stone mass was now releasing stored heat gradually upward through the floor. The system was working even before winter truly tested it. Soren lay in his bed that first night and felt vindicated in ways he could not articulate to the neighbors who thought him crazy. January of 1853 arrived with temperatures that tested every structure on the volcanic plateau. The cold came in waves, each one pushing thermometers lower, 10 degrees below zero, 15 below, 20 below on the coldest mornings. Wind swept across the open country with nothing to slow it, driving the effective temperature even lower. This was the winter that separated adequate shelters from failures. Soren lit his first fire in the new cabin on January 3rd. A small fire, nothing like the massive blazes his neighbors maintained. He used seasoned pine and fed the flames just enough to keep them alive. The fireplace drew well, pulling smoke up the narrow chimney efficiently. Heat radiated from the firebox into the cabin space, but the fire itself was not the primary heat source Soren was monitoring. He had placed a thermometer inside the cabin, mounted on the wall 5 feet above the floor. Another thermometer hung outside the door. The comparison between interior and exterior temperatures told him everything he needed to know about his system's performance. On that first evening, with a small fire burning, outside temperature was 8 degrees. Inside temperature was 64 degrees. The floor temperature, measured by laying the thermometer directly on the planks, was 68 degrees. The floor was warmer than the air. This was the confirmation Soren had worked toward for 9 months. Heat was radiating upward from the volcanic foundation, warming the floor planks, which then warmed the air above them. The small fire supplemented this baseline warmth, bringing the total interior temperature to comfortable levels. The system worked exactly as he had theorized. Over the next week, Soren refined his fire management. He discovered he could let the fire die completely overnight. The floor retained enough warmth to keep the cabin interior above 50 degrees, even with no active fire. In the morning, he would rebuild a small fire that brought temperatures back to the mid-60s within an hour. Total wood consumption was a fraction of what he had burned in his previous cabin. The volcanic foundation's thermal performance improved as winter progressed. The stone mass had absorbed heat through spring, summer, and autumn. Now it was releasing that stored energy gradually. The release rate was slow enough that the foundation would provide warmth for months. Soren understood he was living inside a giant thermal battery that charged during warm seasons and discharged during cold ones. By late January, outside temperatures had dropped to 29 below zero on the coldest morning. Inside the cabin, with a fire that barely qualified as such, the temperature held at 72 degrees. The floor measured 74 degrees. Soren walked barefoot across the planks, feeling warmth that would have been impossible in any standard frontier cabin. The contrast between interior comfort and exterior brutality was extraordinary. Neighbors had not yet seen the results. Soren lived alone and received few visitors during deep winter, but the testing would come. Winter always found weaknesses in construction and design. Soren's cabin would either prove itself or fail. The evidence so far suggested it would do more than merely survive. February brought weather that frontier settlers would remember for years. The cold intensified beyond normal winter severity. Temperatures dropped to 30 below zero and stayed there for days at a time. Wind created conditions that made outdoor exposure dangerous after minutes. This was survival weather, the kind that killed livestock, froze water supplies solid, and tested whether cabins could sustain human life. Across the scattered settlement, families burned wood at desperate rates. Bjorn Lunde's woodpile, cut and stacked through the entire autumn, diminished visibly week by week. He kept 2 fires going constantly, one in the main fireplace and another in a smaller hearth on the opposite wall. Both fires consumed wood faster than seemed possible. Despite this, the dirt floor of his cabin stayed frozen. His children slept in layers of clothing and furs, huddled as close to the fires as safety allowed. Magnus Viker faced similar conditions. His cabin was slightly better built than Bjorn's, with tighter chinking and a more efficient fireplace. It made little difference. The cold came up through the dirt floor like water rising through sand. His wife, Sigrid, developed chilblains on her feet from constant exposure to the frozen floor. She wrapped her feet in wool and leather, but the cold penetrated everything. Walking across the cabin floor was painful despite multiple layers of insulation. Leif Nordstrom lost 3 sheep to the cold. The animals had been sheltered in a rough shed, but the structure provided inadequate protection. Leif found them frozen on a morning when the temperature had hit 34 below. The loss was significant economically and practically. Those sheep represented food and wool the family would not have. Winter was revealing the cost of marginal preparation and inadequate shelter. Soren's cabin existed in a different reality. Outside temperatures identical to what his neighbors endured produced entirely different interior conditions. On the morning Leif's sheep froze, Soren's interior temperature was 71 degrees. His floor measured 74 degrees. He maintained a fire so small it would have been laughable in any other cabin. A few pieces of wood burning lazily, producing minimal flame, barely qualifying as a heat source. The volcanic foundation was performing beyond even Soren's optimistic projections. 30 tons of basalt, charged with heat absorbed over months of sunshine, released energy with remarkable consistency. The thick stone mass acted as a thermal flywheel, resisting temperature changes in either direction. When outside temperatures plummeted, the foundation continued radiating warmth at essentially the same rate. The floor stayed warm. The cabin stayed comfortable. Soren's wood consumption during February was approximately 1/5 what he had burned the previous winter in his old cabin. He was using less wood during the coldest month on record than he had used during moderate cold the year before. The efficiency gain was dramatic and measurable. His woodpile, adequate but not excessive, showed little depletion. At current consumption rates, he had enough wood to last through 2 more winters without cutting additional fuel. The isolation of winter meant Soren's situation remained unknown to his neighbors. They were struggling to survive in their own cabins and had no reason to check on the man they considered foolish. Magnus Viker appeared at Soren's door on February 20th, 1853. It was mid-afternoon. The temperature was 22 below zero. Magnus looked exhausted and desperate. His face was weathered from cold exposure. Ice had formed in his beard. He asked if Soren could help. Sigrid was ill, weakened by cold and developing symptoms that looked like pneumonia. Their cabin was too cold. The fire could not keep up. Sigrid needed warmth, or she would die. Soren did not hesitate. He told Magnus to bring Sigrid immediately. Magnus rode back to his cabin, wrapped Sigrid in every blanket they owned, and brought her on horseback through cold that was dangerous for the trip alone. When he carried her into Soren's cabin, the temperature difference was immediately obvious. Magnus stood in the doorway holding his wife and felt warm air radiating from the interior. It made no sense, given the weather outside. Soren helped Magnus settle Sigrid on the sleeping platform. She was conscious, but weak. Her breathing labored. The warmth of the cabin was the first comfort she had felt in weeks. Magnus stood in the center of the room, trying to understand what he was experiencing. The cabin was warm, genuinely warm. The small fire burning in the fireplace could not possibly account for the temperature. Where was the heat coming from? Soren pointed at the floor. Magnus looked down. The floor planks were bare pine, nothing unusual about their appearance. Soren told him to remove his boots and stand on the floor. Magnus did so, skeptical. His feet touched the planks, and he understood immediately. The floor was warm. Not slightly warm, genuinely, noticeably warm. Heat radiated from the wood into his frozen feet. He stood there for a long moment, feeling warmth he had not experienced in his own cabin all winter. Magnus asked how this was possible. Soren explained the volcanic foundation, thermal mass, heat storage, and release, the entire system he had built over 9 months while his neighbors watched and mocked. Magnus listened with growing comprehension. The massive stone platform beneath the cabin was not just structural support, it was a heating system, 30 tons of rock storing and releasing heat. The concept was so simple and so revolutionary that Magnus could not understand why no one had thought of it before. Sigrid remained in Soren's cabin for 3 days. The warmth allowed her body to fight the illness without the additional stress of constant cold. Her breathing improved. Color returned to her face. She slept without shivering for the first time in weeks. Magnus stayed with her, sleeping on the floor near the fire, though the fire was barely necessary given the warmth radiating from beneath. During those 3 days, Magnus studied every aspect of Soren's cabin. He examined the foundation from outside, walking around the stone platform and understanding its massive scale. He looked at the floor construction from beneath, seeing the air gap and understanding how heat transferred from stone to wood. He asked detailed questions about stone selection, foundation building, and thermal performance. Soren answered everything. Magnus and Sigrid returned to their cabin on February 23rd. Sigrid had recovered enough to travel, though she was not fully well. Magnus had promised to keep their fire higher and had asked Soren for advice on improving their cabin's heating. Soren suggested basic improvements: sealing floor gaps, improving chinking, building a reflective back wall behind the fireplace. Small changes that would help but could not replicate the volcanic foundation's performance. 2 days later, Bjorn Lunde appeared at Soren's door. He had spoken with Magnus, who had told him about Sigrid's recovery and the warmth of Soren's cabin. Bjorn was skeptical but curious. Could he see this warm floor for himself? Soren invited him in. Bjorn stood in the cabin's center and felt the same shock Magnus had experienced. The cabin was genuinely warm, despite outside temperatures in the teens below zero and a fire that would not heat a storage shed in normal construction. Bjorn removed his boots without being asked. He stood on the floor and felt heat radiating into his feet. He walked across the cabin, checking different areas. The entire floor was uniformly warm. This was not a hot spot near the fireplace. This was consistent warmth across the entire floor surface. Bjorn asked the same question Magnus had asked. How was this possible? Soren gave the same explanation. Volcanic rock foundation, thermal mass, heat storage through warm months, gradual release through cold months. The stone beneath the cabin weighed approximately 30 tons. It had absorbed solar energy and geothermal warmth for months. Now it was releasing that energy upward through the floor. The system required no fuel beyond the initial construction labor. It worked continuously without intervention. Bjorn's skepticism dissolved into something approaching awe. He was a practical man who understood value when he saw it. Soren had built something that fundamentally solved the primary problem of frontier winter survival: staying warm. Not merely surviving the cold, but living in genuine comfort while using minimal firewood. The implications were obvious. Anyone who built this kind of foundation would spend winters in warmth while using a fraction of the wood other families burned. Word spread rapidly through the small settlement. Within a week, 4 other men had visited Soren's cabin to see the warm floor. Each experienced the same progression: skepticism, shock upon entering, disbelief at floor warmth, questions about how it worked, and finally understanding that the massive stone foundation was not foolishness, but brilliance. The man they had mocked for 9 months had solved a problem none of them had properly understood was solvable. The questions became more technical. How deep was the foundation? What kind of stones worked best? How were they stacked? What about the air gap beneath the floor? How long did construction take? Could this work with sedimentary rock, or did it require volcanic basalt? Soren answered patiently, sharing everything he had learned. He had no interest in keeping secrets. If others could benefit from warmer cabins, that was acceptable. Spring arrived in late March, with temperatures that finally climbed above freezing during daylight hours. Snow melted in patches, revealing the volcanic plateau's characteristic black soil. Men emerged from cabins to assess winter damage and begin planning for the season ahead. The brutal winter of 1852 to 1853 had killed livestock, depleted wood supplies, and left families exhausted from months of fighting cold. Everyone who had survived wanted better preparation for the next winter. Leif Nordstrom was the first to approach Soren with a direct request. Could Soren help him build a volcanic foundation for a new cabin? Leif had visited Soren's cabin twice during late winter and understood the system's value. He was willing to invest the labor required if it meant his family would spend next winter in warmth instead of desperate cold. Soren agreed to help. They began work in early April. Leif's cabin site was located a mile south of Soren's location, near a small creek that provided water year-round. The site had good drainage and southern exposure. More importantly, it was within reasonable distance of lava fields where volcanic basalt could be harvested. Soren explained the entire process: stone selection, transport, foundation construction, floor system design, every detail he had learned through trial and observation. The stone selection took 3 weeks. Soren taught Leif how to identify dense basalt, how to test stones acoustically with a hammer, how to judge appropriate size and weight. They marked stones across the lava field using the same white quartz cairn system Soren had employed. Leif was younger and stronger than Soren. He could move larger stones with the heavy sled. They decided on slightly bigger average stone size, which would reduce total stone count while maintaining thermal mass. Hauling consumed most of May. Leif built his own sled based on Soren's design but reinforced for heavier loads. He could move 6 to 8 stones per trip compared to Soren's 4 to 6. The work was brutal, but Leif had watched his children suffer through winter in a cabin that could not keep them warm. The memory drove him through exhaustion and physical pain. Every stone hauled was a stone that would radiate heat next February. Foundation construction began in early June. Soren guided the work but let Leif do most of the physical labor. The younger man needed to understand the principles through direct experience. They excavated the foundation area, laid crushed rock base, and began stacking courses. Soren emphasized the importance of air gaps, thermal contact between stones, and structural stability. Each stone needed to be placed with intention, not just stacked randomly. By late July, Leif's foundation was complete. The platform was slightly larger than Soren's, 22 feet by 26 feet, using approximately 650 stones. The total mass was heavier, perhaps 35 tons. Leif began cabin construction immediately, working through August to get walls and roof finished before autumn. His cabin would be ready for winter testing. Bjorn Lunde watched Leif's progress through summer with increasing interest. He had been the most vocal skeptic of Soren's original project. Now he was reconsidering. His own cabin had barely sustained his family through the previous winter. By autumn of 1853, 3 families were living in cabins built on volcanic foundations. Soren's original structure had proven itself through one brutal winter. Leif Nordstrom's cabin was newly completed and ready for testing. Magnus Viker had spent the summer building his own foundation, working alone but consulting frequently with Soren on technical details. Each foundation showed variations that reflected individual builders' interpretations of the core principles. Magnus had built a thinner foundation using smaller stones. His platform was only 20 inches thick compared to Soren's 30 inches. Magnus reasoned that less mass would heat and cool faster, potentially providing more responsive temperature control. The trade-off was reduced thermal storage capacity. Magnus's foundation would release its stored heat faster, requiring more frequent fire supplementation during extended cold periods. It was a calculated compromise between construction effort and performance. Leif's foundation incorporated a deliberate innovation. He had created larger vertical air channels through the stone mass by carefully aligning gaps in each course. These channels were approximately 4 inches in diameter and ran from the foundation's bottom to its top surface. Leif theorized the channels would improve heat distribution by allowing convective air circulation through the stone mass. Warm air would rise through the channels, drawing cooler air from below, creating continuous circulation that would move heat more efficiently than conduction alone. Anders Solberg, a surveyor who traveled through the region that summer, spent 2 days examining all 3 volcanic foundation cabins. Anders was educated, one of the few men on the plateau with formal schooling in mathematics and basic engineering. He understood the thermal mass principle immediately and recognized its significance. He took detailed measurements and made sketches of the construction techniques. Anders saw applications beyond individual cabins. Anders suggested modifications based on his engineering knowledge. The foundations could be improved by varying stone density through the vertical courses. Denser stones on top would provide better thermal contact with the floor. Less dense stones at the bottom would provide insulation from ground cold. The gradient would optimize heat storage in the upper courses where it was most useful for floor warming. None of the existing foundations used this refinement, but Anders documented it for future builders. The geographic spread of the technique began that autumn. Anders carried knowledge of volcanic foundation construction to other settlements during his survey work. He visited homesteads in eastern Oregon and western Wyoming where volcanic rock was abundant. He explained the principle to builders and settlers, showing his sketches and describing the performance characteristics. Several families began planning volcanic foundations for construction the following spring. Bjorn Lunde finally committed to building his own foundation in September. He had resisted through summer, still reluctant to invest the enormous labor required. But the memory of the previous winter and the visible evidence of warm cabins occupied by Soren, Leif, and Magnus overcame his hesitation. Bjorn began stone selection in late September, working frantically to accumulate enough material before winter stopped construction. He would not finish a complete foundation before snow fell, but he could make significant progress and complete the work next spring. The technique was evolving beyond Soren's original implementation. The winter of 1853 to 1854 provided the second major test of volcanic foundation performance. The cold was less severe than the previous winter, but still brutal by any standard. Temperatures regularly dropped below zero. Wind swept the plateau with consistent force. Standard frontier cabins required constant fires and heavy wood consumption. Volcanic foundation cabins performed as their builders had hoped. Leif Nordstrom's cabin maintained interior temperatures in the high 60s with minimal fire supplementation. His larger foundation mass and improved air circulation through vertical channels worked as designed. The floor stayed consistently warm, measuring 70 to 72 degrees throughout winter. His family spent the season in comfort that contrasted dramatically with their previous winter's suffering. Leif's children played barefoot on the warm floor, something impossible in standard construction. Magnus Viker's thinner foundation showed different characteristics. It responded more quickly to temperature changes, but required slightly more fire supplementation than Soren's or Leif's cabins. Magnus maintained small fires more frequently, burning perhaps 30% more wood than Soren, but still far less than standard cabins required. The trade-off between construction effort and performance proved acceptable. Magnus's family stayed warm through winter with wood consumption they could sustain. Word continued spreading through informal networks that connected scattered frontier settlements. Trappers, traders, and traveling craftsmen carried stories of cabins heated by stone foundations. The stories sounded implausible to people unfamiliar with thermal mass principles, but enough witnesses had experienced the warmth firsthand that the accounts carried credibility. By spring of 1854, volcanic foundation construction was being attempted in at least a dozen locations across the volcanic regions of Idaho, Oregon, and Wyoming territories. Not every attempt succeeded perfectly. Some builders used inappropriate stone types. Sedimentary rock lacked the thermal properties of volcanic basalt and performed poorly. Some foundations were built too thin or without adequate air circulation. These performed better than dirt floors, but fell short of the results Soren's careful design achieved. Some builders lacked the patience for proper stone selection and used whatever rock was convenient. These foundations provided marginal improvement at best. Successful implementations shared common characteristics: volcanic basalt or similar igneous rock, foundation thickness of at least 24 inches, careful stone fitting with intentional air gaps, proper floor system with 6-inch air space beneath planks. These elements, when combined correctly, produced reliable heating performance. Builders who understood and implemented these principles achieved results comparable to the original cabins on the plateau. By 1858, volcanic foundation cabins existed across hundreds of miles of frontier territory. The technique had spread organically through demonstration and word of mouth rather than any formal documentation or promotion. Soren had never written instructions or claimed credit. He had simply built something that worked and helped others who asked for guidance. The knowledge spread because it solved a real problem for people who desperately needed solutions. Mortality statistics, incomplete but suggestive, indicated reduced deaths from cold-related illness in areas where volcanic foundations became common. Soren Haldor lived in his volcanic foundation cabin for 16 years. The structure aged well, requiring minimal maintenance beyond routine chinking repair and occasional roof work. The foundation itself remained essentially unchanged from the day he completed it in 1852. Volcanic basalt did not decay or degrade. The stones sat in their courses, stable and solid, continuing to store and release heat with the same efficiency they had shown during the first winter. Soren never remarried. He lived alone, trapping in declining fur markets and eventually transitioning to subsistence farming and occasional carpentry work for newer settlers. He helped build 7 more volcanic foundation cabins over the years, sharing his knowledge freely with anyone who asked. He took no payment beyond occasional meals or traded goods. The technique had saved his life by giving him purpose after Astrid's death. Helping others implement it seemed appropriate. The plateau settlement grew slowly. New families arrived, built cabins, struggled or succeeded based on preparation and luck. Many of the newer cabins incorporated volcanic foundations from the beginning, the technique having become standard practice for anyone building in the region. The dramatic difference in winter comfort between foundation and non-foundation cabins was obvious to anyone who experienced both. Builders who ignored the technique were considered foolish or ignorant. Soren's health declined gradually through his 50s. The years of hard physical labor, brutal winters, and frontier diet took cumulative toll. He developed a persistent cough in 1868 that never fully resolved. By 1869, he was noticeably weaker, moving with difficulty and unable to work as he had in previous years. Leif Nordstrom and Magnus Viker checked on him regularly, bringing food and helping with tasks beyond his diminishing strength. Soren Haldor died on November 3, 1869. He was 58 years old. Leif found him in the cabin, lying peacefully in his bed. The floor was warm. A small fire burned in the fireplace. The volcanic foundation was doing what it had done for 17 winters, radiating steady warmth upward through the planks. Soren had died in comfort, surrounded by warmth that he had engineered into existence through obsessive focus on a problem most people accepted as unsolvable. They buried him beside Astrid on the hillside, overlooking the creek. Magnus, Leif, Bjorn, and a dozen other men who had known him attended. Several spoke briefly about his skill as a builder and his willingness to help others. No one mentioned innovation or legacy. Frontier culture did not emphasize such things. A man was remembered for whether he helped his neighbors and whether his work was solid. By those measures, Soren had lived well. His cabin stood for decades after his death. New occupants maintained it, recognizing the superior construction. The volcanic foundation continued performing exactly as designed, warming floors through winters into the 1880s and beyond. Eventually, the cabin was abandoned as settlement patterns shifted and people moved to developing towns. The logs weathered and collapsed. But the foundation remained, a rectangular platform of dark stone rising from volcanic soil, testament to one man's refusal to accept that floors had to be cold.